This is part 2 of lesson 10-2, measuring angles and arcs of a circle. So continuing on, we have a new problem here where we're working with percentages, and based on those percentages, we have to find the measure of arcs. So I just wanted to remind you real quick, if we have our circle here with a dot in it, that all of the central angles add up to 360 degrees. So if we're talking about a full circle, 100% of a circle, we're talking about 360 degrees, right? So we're gonna say 360 degrees equals 100% of the circle. Okay, so if I had, let's say, boom, boom, this guy, and he is, let's say, 85 degrees, right? I know the rest of this would have to be equal to 360 minus 85. My brain's not awake yet. 275. So this whole angle. And together, they make up the full circle, right? So how can I figure out the percentage that each one makes up, right? Well, if the whole thing is 360 and just this guy is 85, I could write 85 over 360, right? And that's going to give me percentage if I divide and multiply by 100. So 85 divided by 360 equals 0.236, blah, 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 times 100. So that's 23.6% of my circle. 23.6%. This angle is 23.6% of my circle. And this angle is obviously going to be the rest of it, right? I could just subtract that from 100. Or I can say, all right, well then this one is 275 out of the full 360. And if I divide that, change it to a percentage, I get 76.4. 76.4%. So together, these two percentages add up to 100. That's my full circle. This little angle is about almost 24% of my circle. And this big angle is about 76% of my circle. This is a little less than 24. This is a little more than 76. Together, they add up to 100% of the circle. All right, so that's kind of the idea that we're looking at here. All right, show how to find the measure of KL, arc KL. So KL is this guy, and it tells me that that portion of my circle represents 21% of my circle, right? So out of the full 100% of my circle, this is 21. So 21 out of 100 is equal to, if I know it's 21% of my circle, how can I figure out how many degrees it is? Well, the whole thing is 360, right? 360 degrees, so I want to find the number of degrees this is out of the full 360. So I've got just my piece percentage out of the whole circle percentage is equal to just my piece in degrees out of the whole circle in degrees. Kind of making sense? And then we can cross multiply to solve for x. And there's an easier way to do that too. We can also just multiply 360 times 21%. I just wanted to show you where I was getting that math from. Okay, so that's going to give me about 75.6 degrees. If I cross multiply and solve for x, you will get 75.6, which makes sense, right? It's less than 90, but it's still a larger chunk, so almost 90. That makes sense. Let's do B. Show how to find the measure of NJL. NJL. So that's this whole big N through J and then stop at L. That whole big portion right there. This whole thing. All right, so you can do one of two ways. You can either add up all these percentages and figure it out just like we did here, or you can find just this little section and subtract it from the whole thing. I'm just gonna stay consistent and solve it just like I did here. So I'm gonna add up all these percentages, 26, 37, and 21. What was it, 37? And that's going to add up to, what, 47 and 37, 84%, which makes sense because this is 16. So 84% of my circle is this whole big section. So I want to find the measure of the arc, which is the same thing as the measure of all these interior angles added together. We're just not counting this little piece, right? Everything but that. So when I set this up, I can either say, all right, 84% out of the full 100 is the same as how many degrees out of the full 360, and cross multiply just like I did here. Or the shortcut is, since my arc is 84% of the circle and the full circle is 360, I'm going to multiply 360 degrees times 84%, right? Which would be 360 times 0.84. Remember, when you change a percentage to degrees, you divide by 100 and it turns into a decimal. And then when I multiply that in my calculator, 360 times 0.84, I get 302.4. And that's degrees. So whether you solved the shortcut way or you cross multiplied, you would have got the exact same answer for x, 302.4 degrees. This portion of the circle makes up about 84% of the circle. The full 100% is 360 degrees. So 84% is just 302.4 degrees. I hope that's making sense. Let's do another example. Sports. This is a nice colorful example. Refer to the circle graph to answer the question below. A, show how to find the measure of arc EF. So that's just this guy right here. We're just looking for this little red slice, which is soccer. Okay, and it tells us that this represents 14% of the entire circle. So the entire circle is 360 degrees, and we're going to multiply that times 14%. And that's just going to tell us how many degrees this little portion represents. Degrees is out of 360, percentage is out of 100. So they are different. You can't say, well, it's 14%, so I think it's 14 degrees. They don't match up. Okay, so 360 times 0.14 equals, I'm just going to use my calculator, 50.4. 50.4, and that's in degrees. I just changed it to degrees. Okay, so 14% of my whole circle is about 50.4 degrees. All right, show how to find the measure of arc FBC. So FBC is going to be this portion, right? From here to here, this whole guy. So that's made up of 14% plus 20% plus 18%. So 14 plus 20 plus 18 equals 38, 48, 50, 51, 52% of my circle. So it's just over half. So this whole arc here should be bigger than a semicircle, a little bit bigger. 50% would be a semicircle. We're at 52% with all these added together. So just slightly over half. So it's a major arc. And what is that arc, right? So we're going to find 52% of the full circle, which is 360. 360 times 52%, which is 360 times 0.52. Should be bigger than 180. And I got 187.2. So from F to B to C, yes, there's an A here too, but when you name an arc, you don't ever really use more than 3 points, right? 3 points does the job. So even though there's an A here, we could have called this arc FAC. You can't call it FAB because then it wouldn't include this yellow piece. So it either had to be FAC or FBC to show that we went through those points and landed at C. Does that kind of make sense on how to name an arc? If it's just one little portion, then you could just say arc FA, right? If it was just the green guy. But if it's more than that and you're going to have to pass through points and stop at a certain point, you got to be specific. So when you name an arc, you either use 2 points or 3 points. Okay? Hopefully that's making sense. Let me know if that's confusing to you at all, and I'll be happy to explain it in another way. Almost done. All right, arc addition postulate. Fill in the blanks here. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So in this blank right here, we're going to write the word adjacent, meaning they're right next to each other. Okay, so if I were to draw this angle, there's one, and then I added on to it and got this angle, right? There's two, this guy and this guy. So the measure of that full arc is just adding together the two smaller arcs, right? So we're going to say the measure of arc x, y, z, x through y, ending at z, is the measure of arc x, y. When you're talking about an arc, you got to put the little arc over the top, plus the measure of arc y, z. You add these two smaller together to get the big one. That kind of goes without saying, right? Common sense. That makes sense. Okay, so let's do a couple examples with that. Find the measure of LHI. So here's LHI is this portion. Okay, first thing before I can start adding arcs is I want to see how much I can figure out on my own for all these angle measures, right? Well, I know this is 90 degrees, so that's 90. And I know together these three add up to 180 because they add up to a straight line, right? So 90 plus 32 is, well, I know if this is 90, then I know together these two have to be 90. So what 32 plus what equals 90? 58. So this has to be 58. These two angles are vertical, so this has to be 58. And once I know that, I can figure out this big arc right here, right? I can either add all of these up and subtract from 360, or I can say, all right, here's a straight line. These two angles make up this straight line. Or you could say, here's a straight line. These two angles make up this straight line. So 58 plus what adds up to 180? And that would be 122. So now I know the measure of all the central angles, right? Which is the same size as the measure of all the individual arcs. So to find the measure of an arc, I'm just going to add two things together. All right, so for the measure of LHI, LH is 58. The measure of LH, which is 58 degrees, plus the measure of HI, which is 32 degrees, equals the measure of the whole thing, LHI, which is 58 and 32 is 90 degrees. And yes, you can look at it and tell that it's 90 degrees, right? We already said this side is 90, so then this side has to be 90, but you have to show your work. Okay, and then next one B, the measure of IJK. So that's going to be this arc. So I'm going to add IJ, which is 90, plus JK, which is 58. 90 plus 58, I'm just not writing out all the steps this time, is 148 degrees. The measure of the arc, just this orange portion, is 148 degrees because the measure of these central angles together is 148. Okay, so easy peasy, right? The measure of an arc is the same size as the measure of the angle it comes off of. So if it's a pizza slice, you look at what the measure of the pointy end is, and that's the same measure of the crust, right? Same thing. That's how we measure it. All right, so now we're going to move on to arc length. So this is a little confusing because the measure of an arc is in degrees, but the length of the arc is in units, right? Like feet, inches, whatever. And it depends on what the circumference of the circle is, right? You can have a teeny tiny circle and have a 90-degree arc, or you can have a humongous circle or an arena and have a 90-degree arc, and the length of that arc in the arena is going to be way bigger than the length of the arc in a teeny tiny circle. So just because they both have the same measure does not mean they have the same length. So we're going to talk about how to find arc length now. All right, words. The ratio of the arc length, L, we call it L. Let me highlight this. Red. The measure of the arc length, which we call L, to the circumference of the circle is equal to the ratio of the degree measure of the arc to 360. Right? So we're talking about proportions here. So if we talk about the central angle part, right? This guy, this just our portion, that degrees, compared to the entire circle, right? So if this was 10 degrees out of the full 360, that would be equal to just this portion of the arc out of the full distance all the way around the whole circle. So we're writing two ratios here. One's referring to degrees, the arc measure or the central angle measure, and one's referring to the length. So either the length or the distance around the full circle, or just the length of our portion of the circle in our arc. Okay, so the length of our arc compared to the full circle circumference, which is 2 pi r. Remember, circumference equals 2 pi r. That's all the way around the full circle. Is equal to our little our little central angle out of the full sum of all the central angles of the circle. So just our portion, full circle, just our portion, full circle. Length, degree. Hope that's making sense. So if we take the idea of this guy and we just turn it into a formula just to solve for L, how can I take this equation and just get L by itself? Well, I would have to multiply both sides by 2 pi r since I'm dividing L by 2 pi r. So I'd have to multiply this side by 2 pi r, and then this would cancel with this. And then I'd have to multiply this side by 2 pi r. So once they did that, they got this. So you can either say the length of just our arc over the full circle length, the circumference, is equal to the measure of just our arc over the full circle measure, which is 360. If I rearrange that to just get arc length on one side by itself, then I get this times the circumference of the circle. So this is the formula that we're worried about when we're solving for arc length. If you can't remember this or you get confused and this is clicking to you, try and go back to this proportion because it's the same thing. All right, so we're gonna do a couple examples on that. Last page of notes, I swear. Yeah, last page. I have another class notes under. I was like, oh, I put on the other page, but it's not you guys. Find arc length. Show how to find the length of DA in each figure, round to the nearest hundredth. That's important. Round to the nearest hundredth. When we're rounding, we are going to get decimals, so we need to know what to round to. Okay, so for this first one, let's zoom in. Arc length of DA. For every single one of these, we're looking for this guy. Okay, so first thing I want to do is write a ratio of, never mind, I don't want to do that. I want to use my arc length formula. So arc length equals degrees out of the full 360. So my arc here is 40 degrees out of the full 360 times the circumference of the circle. And circumference is 2 times pi times the radius. So 2 times pi times the radius. How do I know what the radius is? It tells me right here. The radius is 4.5 centimeters. So if I'm solving for arc length, the arc length is going to be in centimeters, right? So this is going to represent the full distance around the whole circle. And when I multiply it by this ratio, which is the percentage of just our little piece out of the whole circle, it's going to tell me how long this little piece is, right? So let me simplify that. 2 times pi times 4.5. Never mind, I'm going to do this one first. 40 divided by 360. I'm just going to go in order. Is 0.11111. Then I'm going to multiply it by 2. So times 2. Then I'm going to multiply it times pi. and then I'm going to multiply it by the radius, times 4.5 equals. So the length of my little portion is pi, 3.14. The length of my little portion. How does that work out? How does that happen? Well, if we start simplifying this, think about it for a second. I want you to look at it. Because it does simplify down to pi, and that seems weird because that doesn't always happen. 2 times 4.5 is 9. So this little section right here becomes 9 pi. Same thing, right? And if we simplify this fraction right here, I can divide the top and the bottom by 10, and I get 4 out of 36. And then I can divide the top and the bottom by 4, and I get 1 over 9. So really, for the arc length, I'm multiplying 1 over 9 times 9 pi, right? And when you multiply fractions, you go straight across the top, straight across the bottom. So I get 1 times 9 pi is 9 pi on top. 9 times 1 is 9 on the bottom. And the 9s cancel. So the arc length is the same as pi, which is about 3.14. Kind of sort of makes sense. That was a confusing one to start with. Okay, let's do another one. They're all set up the same, so hopefully you'll see a pattern here. Now we want to find the length of DA. There's no other points in that arc name, so we know we're not going this way around the circle, just this way. Okay, it gives us this measure, but this is not the angle we're solving for. So we know this is a straight line, 180, minus this little portion is going to give us the rest of this. So 180 minus 28 is 152. So our arc is 152. So the length of our arc, I'll do it in purple this time, length equals our degree of our arc, 152, out of the full circle, times the circumference of this circle, so 2 pi r. The other thing you can do for circumference is diameter times pi, right? Because 2 times the radius is the diameter, so 2 pi r is the same thing as d times pi, right? And the diameter here, it tells us, is 12. So I'm going to do 12 times pi. If you don't want to fool with all that, that's confusing. If the diameter is 12, then you know the radius is 6. So you would write 2 times pi times 6, which is 12 pi, so same thing. All right, so then we want to start simplifying this in our calculator. 152 divided by 360 equals that. And then I want to multiply it times 12 times pi, times 12 times pi. So I get about 15.92. It said to round to the nearest hundredth. So I look at that one. The number to the right of that one is a 7, so I'm going to round it up to a 2. 15.92. Length equals 15.92. And one thing I forgot to do in part A was put centimeters. Don't forget to write your units of measure. That's super important. So here, our unit of measure is also in centimeters. So it's about 15.9 centimeters. If 12 pi is the length of around the entire circle, 12 pi is equal to about 30, almost 38. So if the distance around the whole circle is 38, then just my little portion distance right here is almost 16, right? Which is less than half, so that makes sense. So distance around the whole circle, my little portion length, my little portion distance. That's all we're finding. Here, same thing, we're looking for DA again. It looks like a similar portion of the circle. This guy. This time it's 140 degrees. Okay, so for the arc length of this guy right here, it gives us the radius. You can always tell if it's diameter or radius. Radius is centered, the measurement is centered on the radius. Here it was diameter and it's centered on the diameter. So we know this isn't radius because it's not centered right here. This guy's not diameter because it's not centered in the middle of the diameter. It's just the radius. Okay, so I'm going to put the length of just this little guy right here, the length of our portion of the pizza crust, our arc, is equal to our angle measure out of the full circle times the circumference of the circle, 2 pi r. So 2 times pi, and our radius is 6. Okay, so this actually is the same as this guy. The diameter was 12, which means radius was 6. Here, 6, 6, so the diameter is 12. It's the same thing, just named it different. Okay, so now I can start simplifying. I'm going to start by dividing. I'm just going to go in order. So 140 divided by 360. That times 2 times pi times 6. Oops, you can't see because of the glare. Times 2 times pi times 6. 14.66. I have to round to the nearest hundredth. 14.66. Length equals 14.66, and this is in centimeters as well. So we have to put centimeters. Which makes sense. That's a little bit smaller than what this guy was. This measure was 152. This measure is 140. This is a little bit smaller than 152. So it makes sense that the length around the circle would be a little bit smaller if the circles are the same size, which they are because they both have the same radius and diameter. Okay, let me know if you're getting confused on any of that. Restaurants. When I say let me know if you're getting confused, please do, because some people will watch this a million times and say, I don't understand where you're getting these numbers or why you're doing what you're doing. Don't half listen to this one time and then email me and say, can you help me with this problem? Because you got to put the work in. You got to watch the video and try, and then if you're still stuck, then it's my job. I'm super happy to help you figure it out. All right, last question of the notes. Restaurants. The graph shows the results of a survey taken by diners relating what's most important about the restaurants where they eat. So all this stuff like how great the food is, how important is that when you eat, how quick is the service, how reasonable are the prices, is it expensive? Some people say, I just don't know. I don't know what affects what I like about it. The atmosphere, is there live music, right? So this is what they kind of told in the survey. Show how to find the measure of arc AB. AB is this orange portion right here. And so that's represented by 22%, right? And we're finding the measure. Pay attention because we just talked about arc length, but this doesn't say length. It says the measure of the arc. So now we're going back to our percentages. This is 22% of the full circle, right? The full circle is 360 degrees. So I'm going to multiply 360 times 22%. 360 times 0.22. And in my calculator, when I do that, I get 79.2 degrees. That's the measure of this angle right here. 79.2 degrees. Okay, this portion, this orange slice, represents 22% of the full circle. If the full circle is 360 degrees, then this little orange slice is about 79.2 degrees. Show how to find the measure of BC. BC is just this little guy, right? The quick service, and it's 8%. So we're going to multiply 360 degrees times 8%. And you know how to write 8%, so I'm just going to go ahead and change it to a decimal, 0.08. Don't assume you know how to change it in your head. Always divide by 100 to change it to the decimal. 360 times 0.08, 28.8 degrees. If you put 0.8 here, because it's 8%, so 0.8, that's really, 0.8 is really 80%. Think of it like money, right? If I had 0.08, that's 8 cents out of $1. If I had 0.8, I could put another 0 behind it. That's 80 cents out of $1, right? So be careful about changing percentages to decimals because 8% is this guy, 80% is this guy. So just divide it in your calculator by 100. You'll always get the right thing. All right, lastly, C, describe the type of arc that the category great food represents. So is it major, minor, or semicircle? Great food is this blue portion right here, this huge blue portion. Is this over half the circle? Yeah, it literally says it's 56%. It's over half the circle. So it's bigger than a semicircle, which means it's a major arc. Major arc. It doesn't ask us for the measure of that arc, but if it did, we would just multiply the full 360 degrees times 56%. Half of 360 is 180. We know this is bigger than a semicircle, so it should be bigger than 180 degrees, but it doesn't ask us to find that. All right, so review the notes, use your notes. These are good notes this week. Write all over them if you can print them. If not, write on your own paper. Do your best, and then let me know if you still need help.